So I think I'm gonna get started here. But before I get started, just from like a show of hands, who here's heard of like MCP, just the model context protocol? Shoot, all right. All right, now of you guys, how many of you like really know like how MCP works, the benefits of it, why people even talk about it? Okay, awesome, all right. So this is exactly what I was anticipating, and I'm really glad. Because if it was the opposite, it'd be a really awkward situation. So, hey everyone, my name is Hari. I work as a data scientist at Autodesk, and today I'm just gonna be breaking down how MCP works and why it's really applicable to larger data sets and just more enterprise scale applications. But before I get started, I do wanna mention one thing. A lot of what I'm gonna be talking about today is a little bit low level, right? I'm always under the impression that as developers, it's really easy to use a tool. Right? It's really easy to download an MCP server from some hub, connect it to like Claude Desktop, and just use it, right? But I feel like the real enablement of developers come from understanding how these tools work, so that you not only get a better appreciation of what's going on under the hood, but really allows you to create something more innovative on top of it. So what I'll be breaking down today for you is threefold. Right? The first two sections are going to just be a bit general, right? Just making sure that we're all on the same page. I feel like a lot of the articles or videos I see on MCP really just focus on the solution, right? But I want to break down where the problem originates from, why MCP works the way it does, and how it tries to at least address these issues. It's not perfect. In fact, the framework I'm going to be using for the coding aspect, which is the majority of what I'll be talking about today, that like repository is still like constantly being updated. So there's a lot of new like methods, a lot of new like instances of MCP being developed like as we speak. So I'll just be talking about the current version as it stands. But overall, yes?
Do you have links for slides or GitHub?
Yes, all that will be at the end, unfortunately, yes. But right now, we'll talk about the limitations of current agentic systems, right? So just talking like from a very general stance. Then we'll talk about what MCP is, how it addresses the issues I'll talk about in the first section. Then we'll go straight into the code by using the MCP framework, and then we'll abstract that low-level framework by using Pydantic AI. So let's jump into the limitations of current agentic systems. Now, the main point that I want to make here requires some build-up. So let me take a really big step back and talk about one of the fundamental principles of software development. And that's the idea of microservice architecture, right? Where a service in this architecture refers to an independent program that can do just a small task. But the real power of this system comes from all of these multiple independent programs that allow the system to be modular, scalable, and maintainable. Okay, it's scalable because if one like program fails, the entire system still stays intact. It's maintainable because you can upgrade or degrade one program without impacting the entire system. And lastly, it's modular because there's going to be some repetitive piece of code that you can abstract out, and all these services can read from that like initial like store of reusable code. And unfortunately, the way LLM architecture, or like the way agent architecture stands right now, doesn't really fall into that modular, scalable, and what was the other one? Maintainable pattern for microservices. And the real reason for this is because tools are very tightly coupled to LLMs. All right, so in the middle, I have a very, very simple diagram of a simple agent, right? But in reality, agents can be a lot more complex because you can add a lot more tools. And the way this framework works, say if you use something like LangChain, right? You define a tool, you define the name, the description, the input variables, and all that. But then you have to send that as part of a prompt to the actual agent. Right? That's how the agent knows what to pass into the tool. And obviously, LangChain's executor allows it to like execute actual Python behind the scene. But overall, the tool and the schema of the tool is passed in directly to the agent. And this is really problematic because say that you change the tool, right? Say that you change some of the code, maybe you change the purpose of the tool, maybe you change some of the input parameters. Now you're left in a situation where you have to restart the entire agent system because previously the tool schema was different. So you updated the tool, and now the agent has to take in a new system prompt for the tool schemas, and you have to do this every single time you change the tool, right? And like I said, this is a very simple agent architecture, but in reality, agents can be really, really complex. So having to restart an agent every time you change a tool isn't really scalable, right? And to talk more about why it doesn't fall into the whole microservice pattern, it's called the M by N problem, right? I don't know if this is like a formally defined one or if I just made it up, but the whole idea here is you have M different agents, okay? And each agent is integrated with N different tools. which means in this case, say that you have 10 agents with 10 different tools, you're doing 100 integrations. And each integration means you're passing in the tool schema to the system prompt, and each tool is the same, except you're passing that same schema 10 different times to 10 different agents, and if that one tool changes, then you have to redo that same thing over and over again. Right? So you have this exponential growth problem, especially in an enterprise setting where you're probably going to have multiple agents to do multiple different tasks. This is not really that scalable, and it's not maintainable at all. And then the next 2 points echo what I just said, tool duplication, right? The same tool is being duplicated 10 times and fed into 10 different agents. And it's not modular in the sense that you change the code of one tool and you have to restart the entire system. So how does this impact workflows in a larger team and just an enterprise setting in general? Right? The main thing is most teams have a siloed purpose, right? You have one team that's for front-end development. You might have another team that's actually like only just the back-end, integrating the front-end to the back-end, the agent service. And you have another team that's doing the actual agents. If all of these teams are making their own individual tools, if all of them are updating their own tools as they're doing it, it leads to a lack of standardization. And one of the biggest emphasis in like enterprise level development is the idea of having some like core structure for standardization. Everyone makes tools a certain way. Everyone accesses tools a certain way. And it makes sure that all these problems are mitigated because of the fact that everyone is only following one standard. But because tools are so tightly coupled to LLMs, it's hard to have that standardization because you can't have a central repository of tools when all the tools have to be fed into an individual LLM, for example. So this is where MCP comes in, all right? What exactly is MCP and how does it address this issue? So I'll just read off like the definitions you'll find on like Wikipedia. So MCP is an open protocol standardizing how LLM agents and tools interact. It decouples tools from LLMs, enabling modular, plug and play, integration, yada, yada. All right, so what does this mean from more of a layman terms? I have a simple like diagram on what MCP is trying to do, and I want to take some time to focus on this because this is what we're going to make in a more simplified version of this. On the left-hand side here, you have the system that consists of your front end and the back end, and for now, we'll call that the MCP client. All right? On the right-hand side here in pink, we have labels that represent the MCP server. All right? And the client talks to a server, there's nothing too special over there. The real key here is what the protocol defines. Right? A protocol just defines a set of methods that you can use for a client to communicate to a server. If you think of something like RESTful, right? You have get, you have put, you have post, and all that. The same thing is true in MCP, except we need to define what those protocols are, what those methods are. And the key here that really mitigates the problems that I just talked about is that every server has tools defined in it, but you don't send them to the MCP client immediately. By the way, the MCP client is where the model is hosted. What the model does instead is that it uses the MCP protocol to discover what tools are available based on the user's input and invokes those tools on a dynamic basis and in a way to like supersede the problem of having tools inputted directly to the model. That was a bit confusing. I didn't actually do the best job explaining it, so let me try again. Right? The MCP client has an LLM. But unlike traditional LLMs, you don't feed in the tool schema in the system prompt. You just feed in the question, maybe just like, hey, you're a person that can do X, Y, Z, and you need to answer the user's question. What the MCP LLM has access to, though, is the fact that there's these servers that could help you out in addressing this, the user's question. Each server has these descriptions. If you want to learn more about a server, let me know, or let the server know, and they'll tell you what each server does. Right? So the MCP client takes that question and it wants to know what this messaging server does. Because maybe the user said, hey, I want to text so-and-so, I'm back from lunch, right? So this server, because it has a description that says I can send messages, the MCP LLM hosted on the MCP client will ask the server, what can you offer me, right? So that server says, hey, I have a tool that will let you message anyone in Slack. I also have a tool that will let you message anyone on Teams. Is any of that helpful? In this case, it is. So it will ask for the schema of that tool. So it's now like a recursive call. Once it gets that schema, it'll pass in the proper arguments based on the user's input, and the tool will invoke it, and the message is sent. Okay? In fact, what I just described from an engineering stance is pretty similar to what you do regularly when you bind LLMs to tools. But the key innovation here comes when you want to add another tool. Right? When you want to add another tool, say you want to add a tool for Discord. Right? All you have to do is just write the code for messaging on Discord and attach it to the server, and that's it. The server takes care of the communication between the LLM and the tool. right? The LLM itself is not directly responsible for maintaining and invoking the tool. And as a result of that, you can add as many tools as you want without having to restart the system, because the MCP protocol allows the LLM to discover what tools are available for it to invoke and send a message to the user or whatever the user's question is. So I hope that part is clear. The main thing here is that we don't need to restart the system over and over again, but when we add a new tool, the server might need to be restarted, but the server is a microservice. Restarting a microservice is so much easier than restarting the entire monolithic service. So once again, the main reason why MCP addresses these issues is primarily, honestly, the top left reason, which is dynamic tool discovery. You don't feed in all the tools at once. You let the LLM discover what it has available, and ideally, it'll discover the right tool or the right set of tools to execute. And as a result, the agents don't need to be restarted every time, because you can just append new tools to the servers, and the servers will expose the tools to the LLM upon request. I think I won't go into most of these other things, but I do want to talk about the centralized tool governance. In enterprise settings, there's always like a governance team, like a data governance team, things like that. And I think like a newly shaping team is like a tool governance, right? In a lot of enterprise applications, you have things like CRMs or ERPs, right? Like a common CRM is Salesforce, a common ERP is SAP. Right? And these are really large databases that host like millions and millions of records. So if each team is creating independent tools to connect to these different services, it's not really that manageable, right? In fact, in production systems, there's a lot of like, there's a lot of what's the word I'm looking for? There's a lot of ownership on making sure that production isn't accessed too frequently, right? And the reason I mention it is because if you had one tool and only that tool can access production, for example, it makes governing the usage of production so much easier, right? And that's what MCP allows you to do. So you don't have multiple teams interacting with production all at once. You just have one team that maintains that connection and gives it access to other teams upon request based on some business justification. So let's jump into the code. I hope that gave enough of a background here. Actually, I lied. Let's talk about what we're going to build first, and then we'll jump into the code. So over here, I made like a really simple diagram of what we're going to build today. Unfortunately, I am not a UI developer, so my UI is going to be the terminal, right? But what we're going to make today is a personal finance assistant, all right? Where the key principles I want to highlight to you is how exactly MCP is able to communicate to multiple different servers to address the user's question. All right, the main tools that'll like store our data, for example, is going to be Google Sheets because it's free and it's a really nice database because Google doesn't really charge for the API as much as like any other like hosted database. We'll also have features to like have the user send themselves an email or some reporting based on their transactions. So this is the QR code for the GitHub repository. I'll just be on this slide for a second before I switch over to my VS Code. All good? Yes, yes. I'm seeing some yeses, so I'm going to switch over. Awesome. Oh, okay. All right, so just a few things. If you do want to follow along, I apologize. The setup is a little bit lengthy, but I documented it all down here. Okay. One thing I will say that I made for this demo is that I created a fake Gmail account called aiuc.mcp.demo@gmail.com. The main reason is that think of this as like my personal Gmail account, and so I want like an assistant that can help me understand my finances, and this is where I will have like my Gmail ecosystem. Within this Gmail ecosystem, I have a dummy set of transactions. Once again, how you can acquire this and like how you process this is in the GitHub repository. But it's super simple, right? We have the date of the transaction, a description, the amount, and the category. All right? By the way, this was just a dummy data set downloaded from Kaggle that I just reformatted it to make it a bit more simple. All right? Last thing is within the Google Cloud Console, right, I created a few API keys, and I enabled the Gmail API, the Sheets API, the Docs API, and the Drive API. All right, once again, this is just me quickly going through whatever is listed on the README file. So let's just jump straight into what exactly, like what it means to create an MCP client and an MCP server. One thing is a lot of tutorials online really just use like Claude Desktop as the MCP client, and I think that's kind of like boring and dumb, so I decided to complicate it a lot. So we'll have a really simple example to start off with. Let me pull up the files for the test server and the test client. I'll zoom in here in a second. All right. Hopefully you can see that. All right, so let me just explain the architecture behind just the generic client and server, and then we'll add on to it to make the servers for Gmail and all the other integrations alongside like a chatbot kind of UI. I will say the most complicated part of this code is actually creating the client, not the server. So I'll start off with the server, then I'll go into the client. But in this very generic example where you just have a simple client connecting to a simple server, I want to explain the flow so that it's easier to understand the flow when it comes to building more complicated servers and clients. Over here, I have the test server, and it's being pulled from the MCP Python SDK. All right, if this is like the one that's the most up-to-date, constantly being maintained, and there's a lot of new updates being pushed. I feel like there was one just a week ago, right? So some of this actually is a little bit outdated in the sense that a week ago they didn't have the feature, so I had to create it myself, and then a week later they had the feature, and I didn't feel like changing it. So I will talk about that when the time's due. So 2 things. All right, let me go back to the slide here. I didn't really explain what these arrows are, right? The arrows express a flow of communication between the client and the server. And there's 2 ways to do this within MCP, within the MCP ecosystem. The one I'm using is called SSE, which is called server-side events, right? Where the server sends events to the client, all right? And that's how the client understands what the server has available. All right? So say, for example, the client invokes the protocol for tool discovery. It'll send a request to the server, and the server will use an SSE communication to output what it has available. All right? So that's what I'm doing over here. I'm setting up a transport mechanism for SSE, and the main way I'm doing that is, where is it? Yeah, right here, create Starlet app. So if any of you heard of Fast API, like the underlying engine behind that, Starlet, and the main reason is that it's really good for async web requests. And within Starlet, I'm creating 2 endpoints. One is the SSE endpoint, and one is the messages endpoint. All right, I'll explain what these 2 are, but you'll see them live when I run it, and it'll make a lot more sense. The SSE endpoint is where the client connects to the server so that the server can send updates to the client. The messaging endpoints is where the client posts messages to the server addresses them and sends a response back. So if the LLM in the MCP client wants to understand what tools are available on the server, it'll make a post to this endpoint. The server will understand the request and send back all the tools it has using the SSE endpoint. So let me quickly run all of this. Server testing. UV run test server. All right, so over here we have our server running, okay? Once again, I'll get into the code just a little bit. I just want you to see what I just explained with the whole SSE and messaging endpoint. All right, and over here, I will initiate the client. UV test, awesome. Oops, let me hit run. And you can see a bunch of stuff just happened there, all right? So let me break it down. What I'm doing here in the client is the first thing I want to do is I want to connect to the server, right? We initiated the server, but the client needs to connect to it. And it does that through the URL where the port in which the server is running. So over here, the port is 8010, and it's connecting to the SSE endpoint. When we connect it to the SSE endpoint, it creates that connection, and it's a long-lived connection. So over time, the client and the server can communicate without any interruptions. And the main thing I'm doing here is I'm using the list tools method within MCP. All right? This is what allows a client to ask a server what tools you have available, and then I'm storing that within the client. So upon initiation, the client will have access to all the tools that a server has. Okay? So you can create a client that just connects to one server. We'll talk about expanding that in a second, but connects to one server. Upon initiation, it always pulls in the most up-to-date tools so that you mitigate that problem of having to restart the application. I'll talk about how you can do this more dynamically. Right now I'm doing it initiation, but in the loop where we have the chatbot, upon every new request, you constantly pull the tools, right? It is a bit inefficient, but still solves that problem of how every single request, you just get an up-to-date metric on what the tools are. Right now, I'm doing it initiation just so it's less complex. From there, all I'm doing here is I'm printing out the tools. So within the MCP server, I define a really, really simple tool called greeting. It takes in a name, and it just prints out how are you doing for that name, right? The way you create this, actually, this is like on the documentation, you have to do it like this. Because this is the schema that's being passed to the LLM for it to understand what the tool is, right? So the tool has a description, which is this. The tool has an argument that has a type of string, and it outputs a string, right? And all of this is important information for the LLM to be able to invoke it, okay? So you can also see that here, where it says connected to the server with tools. And this is the response sent back by the server. The client asked the server what tools you have available, and it gave this object, right, with this name, this description, and so on. And if you look over here, we have some random firing of SSE messages and more messages, right? So this is where the initial connection is made, and it's a long-lived connection. But this messages endpoint is being sent by the client, right? It's a POST request, and the client is asking the server, what tools do you have? And that POST request is initiated by this function. And this session ID, I wouldn't worry about it, but just like is the session in which all the communication is happening. So if I were to stop this program and run it again, it just starts a new session. But that's over the scope of what I want to talk about. So yeah, you go back and forth, and you can see here that eventually the server is going to run its own list tools request, because that's the request it got from the client to list all the tools it has and give it back to the client. All right? So at a high level, this is how MCP servers work. I do want to just pause for 2 minutes and just take any questions, because it will get a little bit more complicated from here on out. It won't be as low level though. Yes?
So what's the difference between this versus how LLM would coordinate, decide the reason coordinate a plan for what to use?
Yeah. So actually from a engineering point of view or from an output point of view, there actually is not much of a difference, right? You pass in all these tools to an LLM. You have, say, an orchestrator LLM that'll do some intent classification, pass it on to some more specialized LLMs, and so on. So in reality, just from a high level, there isn't that difference. It's what MCP brings it more avenues to, right? Like I said, if you want to add more tools to that whole orchestrator thing, you have to stop the agent and re-execute it by pulling in the new tool schemas and everything. Whereas here, and I'll show that in a second, you can just add another tool, and you never have to restart the client. You might just have to restart the server. But if you have independent servers, that's the whole microservice part, then you can just restart a server without breaking the whole system in general. So let me jump into our first example of of a server, and we're going to focus on the Google Sheets server. So this is the server that will allow you to interact with that database, which is just your transactions. All right, so I'm not going to go too in-depth on how the Google API works, because that's not my focus. But in general, we're just using some OAuth credentials to pull in the specific sheet, and that's stored in my env file, which I load up here. I'm not going to show that to you because it has my Anthropic key, and it's not that I don't trust you guys, but I don't want to expose that. But yeah, this is the unique ID for my sheet, which is within the URL, and then this is the specific sheet within it. So it is this transaction sheet. And the main thing I'm doing here is I read it as a pandas data frame, which gives me programmatic access to querying the data frame. And I'll talk about all of these in a second. But I have two primary tools, right? One is sample transactions, which will just get n number of transactions. So if you want 5 transactions, we'll just get 5 random ones. And then I have a tool for adding a transaction, okay? So you can add a transaction by just asking hey, I bought so-and-so for $10, and it'll automatically decide which category to put it, and it'll append it to that respective Google Sheet. All right, so let me go into the starter one so I can code it out with you guys. All right. So to get an understanding of how this server is working, I'm going to run the client. I'm not going to explain how the client works right now. We'll talk about that right after I explain how the server works. All right? So let me open up the terminals again. Let's stop this. Boom, boom. And then, let's see. Let me go back up again. I should have just wrote a script to do all this. All right, so I'm going to run the Google Sheets client that I just showed. Awesome. All right. So now the Google Sheets client is running, and it has these respective tools, those two tools primarily. And now let me run the client. Right. Client. Now, one thing is that it's going to take in two parameters, which is the name of the client and the connection string. All right. So that takes it just as terminal command. So I'll just call this client sheets. All right. And then we're going to copy this connection URL. Now, out of curiosity, I hate to quiz you guys, but is this going to work or not? I mean, it's a 50-50 chance. Okay, it didn't work, all right? And the main reason being is that the endpoint that the client connects to is the SSE endpoint, not the root endpoint. So that's what we defined over here, okay? And so now you run it, and it initialized the agent. You can see that the agent responded to the request. It accepted the connection. And now we're in this infinite chat loop where you get to ask a question. I'll talk about how this chat loop is being created, but for now, let's just ask it a question. I know here that there's a tool for getting some random transactions. So let's invoke that. Let me just ask it the question, give me 5 random transactions I made. All right? So if we go over here, oh my God. It gets this response on the right. I don't know why my VS Code is bugging out like that, but you see here that the response it gets me is, I have 5 random transactions from your financial data, and these are the 5. And these are being pulled from that Google Sheets. All right? And it's a bit harder to see because VS Code decided to do this to me. So let me just run it again so you can see what's actually being happening. I have to kill the process. It does this sometimes. All right. So when I run the entire server again, and I ask it the same question, all right, you can see here that the first thing that the client is doing is asking for the tools that are available. Then it requests to call a specific tool, and then it outputted to the client here. All right? So let's see what's happening within the actual client code. All right? Within this client code, I have this infinite loop, all right, where I define while true. All right? While true, get the user's question, so give me 5 transactions. And right now, I'm just appending it to a self-stored chat history, right, where the user question is this, and the system prompt is pretty simple. You're a helpful assistant with personal finances and so on. All right? The main thing I'm doing here, though, is when the user question is given to the client, it will always pull in a fresh update of all the tools. All right? So this is going to be important for later, but for now, there's going to be 2 tools, so that's what it gets. Then I just structure them in a way that I can use the Anthropic SDK to get a tool-based output from Anthropic. Right, so this is going to be a list of 2 dictionaries that defines the schema for these 2 tools, which is what this method here outputs from the server. All right. From there, I just parse through the response. If there is a tool use, then I invoke that tool by using the server's call tool method. All right. By the way, this is the session I was talking about earlier. This session allows you to communicate to the server. So if Anthropic tells me that, hey, given these tools as an input, which I fetched earlier, and given the user question, I want to execute a specific tool to better answer the user's question, that's what this elif clause is doing. After I do that, I just tell the agent what the output of that tool call was, and then I run it again. And in the next run, if the agent didn't execute a tool, it means that the agent had no need to execute a tool because the user's question was already answered, and that's what I output on the screen down below. Yes? Oh, you can use any other models. I just got some free credits from Anthropic, that's all. Yeah.
It's indicated that there's a certain tool called, but you need more parameters. Do you ever set it up to ask the user for some of the parameters?
Yeah, definitely. I mean, I guess I didn't test that out right now, but yeah, if the user didn't give the proper parameters to invoke a specific tool, it should be able to answer that, and that's just something through the system prompt.
Right. But I mean, okay, so you have designed that.
Not in this, but I guess we can test it out actually, but I didn't like to put that in mind when I was doing it. So up until now, I've just been yapping a lot, right? And I didn't really show the true power of MCP. So I'm about to do that right now, all right? So we have this client, and all it can do is just add transactions and look at some transactions. So let's try to really reap the benefits of MCP and add another tool, okay? And notice what happens when I add another tool. So I thought I would just like code this out, but I am running a little bit short on time, so I will copy it from the master file, right? I have this other tool for metric-specific categories, right? And I have this other tool for getting all transactions. So right now, if I ask the client, how much money did I spend on alcohol? Because that is one of the categories, all right? It's going to try and identify within the server what tools it has access to answer this question. And it should say something about it's not going to be able to answer that, or it doesn't have enough capability, right? So over here, all it did, so what it seemed to do is that it sampled some of the data, found that some of the data is related to alcohol, and it just did that, right? But it didn't have access to the actual ability to create those metrics or anything like that. So without really doing much to the client, let's just add this to our actual server, right? So now we just added 2 tools, all right? And for these 2 tools, I've specified just some function that allows it to take in an operation, like how much money did I spend in total for alcohol, right? And it just does a simple pandas calculation summing up that category for this specific input. And if I ask for an average, it's that same calculation except using mean. All right? You'll notice this little yellow line here where it says it's not defined. This is an enum. So within like Python's typing library, if you want to define a limited set of values an input can take, use an enum. I'm doing that over here for category. So category can only be one of these specific values. So for operation, I only want it to be either a sum or an average. So let me pull that over here. I think I have it defined up here. Yeah. Awesome. All right, so now I'm going to save this. So the server now has those new tools, except the server is already running, so I just need to restart the server. Not sure why it keeps doing this. All right. So I unfortunately had to restart the server, which killed the connection. So let me just run the server again. And over here, I'm not going to change the client. I'm just going to run the client as is, right? So I didn't change any of the code with the client. And let me ask it the same question. How much money did I spend on alcohol? Yes, sir. How much money did I spend on alcohol in total? Maybe just to give it a little bit more of a prompt. So here it's listing the tools. In this case, it's going to be a more refreshed list of tools. And here you can see it's calculating the sum for the alcohol category, and it said I spent I swear I did not, but I spent $500 on alcohol, all right? But I really hope you understood kind of what just happened there, right? I know I had to restart the server because restart the client because I killed the server, but I didn't change anything in the client, right? In reality, there is a way to make sure that if you restart the server, the session is still maintained. I just couldn't figure it out. But the main thing here is that the client never changed, right? I just added another tool to the server, and because upon every user request, you fetch an updated list of tools, right? The client is able to know which tools it has access to. Right? So if I want to go ahead and change this tool, right, I no longer have to do some weird thing where I have to restart the entire system. I just have to restart one microservice, which in this case is the MCP server regarding Google Sheets. All right? And that's the real power of MCP right there, the fact that you don't have to restart an entire system, because that's a very costly effort right there. In fact, just as a side note, I believe when you just connect to Anthropic, that itself is a pretty heavy operation, almost as heavy as just getting a chat completion. Right? So connecting to Anthropic and getting a chat completion every single time you want to do a whole refresh on the tools doesn't make much sense. Whereas over here, you just have to refresh the server. Let's see how I'm doing with time. Awesome. All right. So in the next few minutes, I hope that was clear in terms of just one client. Yeah.
So the client is a list of tools. How does the client know a particular operation?
Yes, so that's mainly just based on the LLM's ability to understand the user intent. So over there, I clearly asked it like, hey, I want an ability to see how much money I spent on alcohol. And I really wish I chose a better example because now I whatever, right? And the reason why it's able to call that specific tool is because upon every request, like I mentioned, it's fetching a fresh list of tools, right? And if I zoom in here, this fresh list of tools has the name, the description, and the input schema. So on the server, if I add a new tool, all it's going to do when it pulls up all the tools is just add another JSON here or another dictionary with that specification. And then I pass all of that in to the actual Anthropic completion, which means upon every new request, even if there's a new tool, it's going to understand what tools are available. And now this just comes to your whole prompt engineering. You want to make sure that the documentation on the tools are proper enough so that it's able to accurately identify which tools or set of tools to use. Yes, they are very important. In fact, even this args is really important because the args are also passed, and the args let you know what exactly an operation is and so on. So that is really important. Also, sorry, I will take questions in the end. I just want to cover one more topic. So right now we covered one client and one server. But like I said, a server is just a microservice. It does a very small, unique task. The real power of MCP actually goes beyond the idea of identifying what tools a server has, but it goes into the idea of identifying what servers are available to me, and then going a level down deeper and saying what tools does that server have. Okay? Now, this is kind of going to the whole intent classification, where you have an agent, you try to identify which individual agent to pass that request to, and then that individual agent does something similar to answer the user's question, and it just sends it all the way back, right? In fact, if any of you have used LangGraph, it's really good at maintaining a state, passing it through the entire state's machine, and then passing it back to get a response. And as I was saying, sorry, what's your name? Danielle. Yeah, as I was telling Danielle, from an engineering perspective, it's that same process, but it's what's happening behind the scenes that makes it the whole modularity and scalability. That's the power of MCP. So let me show you the remaining servers, right? So these remaining servers are very similar to that Google Sheets one I just talked about, except now they interact with other APIs. So this over here allows the user to send an email. Right, so you can ask it questions like, look at 100 random transactions and send me your analysis of it as an email. Right now, it has to communicate to two different servers, the Sheets server and the email server, and it has to look at the tools within each server to identify which tools to execute those tools, and then send the response back to the user. All right, and then over here, I have the doc server, does a very similar thing, except if you want it as a Google Doc instead of an email, you can just send it. Or in general, if you want a Google Doc of how much money you've spent, just some analytics that you want to store in Google Docs, this is what allows you to do. All right, so jumping back to the slides, before we just implement terminal to Sheets with these tools to connect. Now we're adding these other two servers, okay? One thing I didn't touch upon just now, or up until now, is this yellow box, service discovery, okay? I talked about tool discovery, where you ask a server for an updated list of tools, so that's your tool discovery, and then you identify which tool to invoke. But service discovery is a little bit different. In fact, 10 days ago, I believe, the actual MCP Python framework I'm using didn't have an implemented way of doing this, hence why I had to hard code it. But I believe there is a way, don't quote me right now, but I believe there is a much simpler way than what I'm going to show you. But essentially what they're doing is what I implemented just behind the scenes. So maybe you might find it cool. The idea here is you want to give the LLM the ability to understand what servers it has available, right? And it's that same idea. Anytime a user asks a question, you first tell it what servers it has available. Then it'll use its own reasoning to figure out what tools individual servers that may correlate to the user input have, then invoke those tools, then answer those questions, okay? And right now, the way I'm updating the amount of servers I have for the MCP client to use is just through a YAML file, okay? So let me open up this. I have a servers key, right? And servers has 3 values: the name of the server, which is just the Sheets, Docs, and email, and then the description of the server and how to connect to it, right? So you can imagine if I add another server, I just have to add another line, okay? And then if I add 20 new servers, I just have to add 20 new lines and so on. Now, before I showed you the code for just a client, right? And I mentioned to you that for the client, I'm just invoking all the available tools based on what the server gives me. And then I invoke the tool if Anthropic wants to call it, show it that output, and it keeps doing that over and over again until Anthropic gives me a final answer. From a multi-client perspective, it's pretty much the same idea, except it just looks more complicated because now you're doing more recursive calls. Right now it's just not one layer, there's 2 layers, right? In the sense that there's multiple servers you have to communicate to. So I'm gonna go by this step by step, and I think by understanding this, you'll get a really good appreciation for why MCP servers can be thought of as microservices and how to pool them together to create some system. The first thing here is that same system prompt. You're just a personal finance agent. I create my connection to Anthropic, and I have 2 very key internal state variables: knowledge gathered so far and tools discovered. And I initialize them as such, right? At the very first, I say the only tool you have access to is a tool that allows you to learn about a server. That's it. Okay, you don't have, yes?
So the knowledge discovered so far, is that some kind of JSON structure, or what's getting passed from agent or something?
Yes, but I'll explain that in a second. But yes, right now it's just a tools discovered, which is just a tool to learn more about other servers, and that's it. And what this knowledge gathered so far is, initially, it's just going to be all the servers and their descriptions. So when you initiate this client, you want to load in a set of servers. And for each server, I just pass in the name and the description, which is coming from that YAML file. So at the very initial stage, you initialize the object, you load in the servers, and these 2 variables just contain information about the server and a tool that allows you to learn more about a server. All right? And then within this overall loop, I'm doing something that you all have heard of, but I'm not going to tell you what it is until I explain it. All right? The very first thing I tell the LLM to do is, hey, you need to answer a user question, which is down here. You have access to these tools so far. Tell me what you want to do. All right? That's pretty much what this prompt is. And you can read it if you want, but essentially just execute some tool so I can give you the output so that you can figure out what to do next. All right? So that's what it does, right? It initially just executes, and then there's going to be some tool use. This code is very much the same as before, except I'm just updating the internal state variables on the current knowledge and the outputs of each tool. All right? Once the tool gets an output, it goes back into this next iteration. All right? And within this next iteration, it's the same idea, except we have an updated knowledge state so far. Right? This knowledge state is going to be the output of any of the tools it just asked to execute. The other key thing here is the tools discovered. Right? When you have when the tool to execute a specific server is called, which is what's going to happen initially, it's going to pull in all the relevant tools for that specific server. All right? And that is stored right here. Right? You can see here that I update the tools discovered so far based on what servers it wants to learn more about. So in the initial question, it'll have access to the Sheets, email, and Docs servers. And the user asks the question, send me an email, or something like that. So it's going to invoke this tool on the email service, and then I update the tools discovered so far to include not only the current tool, but the other tools that that service has available. It'll look at those tools, decide if it needs to invoke anything, and so on. And it's the same process I just described over and over again until it comes up with a decision. Okay? Is that part clear in terms of how it's able to identify? Okay. And before I show the output, this is actually an implementation of a very common agentic architecture called React, right? So you've probably used it with LangChain called create React agent. Right? There's also zero-shot agents and everything. The way React agents work is like that. You reason, right? So you give this prompt that tells the LLM to come up with some action, right? Once it comes up with the action, you execute that action and you tell the LLM to do that same process over and over again until it's confident in the answer. So this is pretty much like a hard-coded version of how the React framework is behaving. All right? So in order to run all this, it actually takes a little bit of a setup. So bear with me. I'm going to just go into the final. Let me go into the servers. Awesome. Let me copy this. And so now the first thing I'm going to do is I'm just going to restart the Google Sheets server. I'm going to open up a new terminal. Right? And then I'm going to run the Google Mail server. All right, it's going to ask me to authenticate because it's a really sensitive API, because this API lets you email anyone. So for now, I'm just doing that. And so now we have the mail server running, and then I'm just going to execute the doc server. UV run Google Docs. All right, once again, asking me to authenticate, so I'm using that fake email account that I created. Don't worry about these warnings, it's not production. All right, so now we have 3 different servers running, all right? And each server has that description based on the YAML file. So let's go back to our client over here, and let's run our multi-client system that I just talked about, which is this file. Wait, let me clear the output so it's a bit clear. UV run, boom. Awesome. So the first thing it did is that it initialized 3 different sessions for all of these 3 different servers, all right? So you saw it happen over here, right? You can see it happen over here, and you can see it happen over here. So that's the first step. And when I initialized it, I pulled in the description of all the servers and so on that I just described. So now let me ask it just a simple question, all right? The same thing, let's see. I bought a boba drink for $10, added to my transactions, right? So even though there's multiple servers, there's only one tool it has to invoke, okay? So over here, I'm printing out the messages, and I'm gonna zoom out, right? So this is the React framework running, where messages so far is just that initial state, right? And I won't go into what each string is doing, but you can see here that's looping multiple times, looking at all the servers, all of the tools it has access to, which is why this string gets larger. This is the knowledge gathered so far. And once it gets that knowledge, it'll invoke the proper tool. And you can see here that it successfully added boba drink to the purchase. So if I look down here and I scroll all the way down, you can see that there is an added transaction for boba, okay, based on the format that I gave it. And it also correctly categorized it as food and dining. Okay? And if I were to break this down, it's a little bit messy. I could have done a better job printing it. But the initial message is this. This is the information it has access to right now, which is just information on the servers and nothing else. But then it asked to query one of the servers for tools. And that's what I'm outputting over here. In fact, you can see here that I'll help you add the boba transaction. First, let's understand what tools are available in the Google Sheets service. Because in the Google Sheets service, the description is it has all the user's transactions. And so then it wants to execute the tool called sample transactions within the Google Sheets service. Once it gets the output, it realizes that it has enough information to answer the user's question, and that's what the output down here is. Okay, so let's just do a little bit more something more complicated. Get 10 transactions. And email me your analysis on them. All right? So ideally here, it's going to do that same process again, right? Except now it needs to identify 2 different tools to use and execute them in the correct manner, and then send me the output. So this will probably take a little bit more time because there's multiple tool calls, but 1 second. Also, this is all just some message history that's maintained. So if it doesn't properly do it, I'll have to refresh the message history. Alrighty. So you can see here that email sent successfully was part of the tool invocation. So give it a second to give a response. Awesome, and it did this, all right? So it found 10 transactions, it analyzed them, and then it composed and sent me an email. Right? So if I look over here on my emails, you can see that we got an email just now, all right? It's not the best formatted. It's just within the tool, you have to format it. But this is the email, and it got all of this from the Google Sheets API, okay? So if I were to look at these logs, once again, I apologize. I don't know why my VS Code is rendering everything like this. But you can see here that for the email API, which is not this, yes, over here, this is the format that is being sent right here, okay? Now, what did we just show? We showed that we can just always add another server, like I said, without restarting the whole system, because adding another server just means creating that microservice. Keep in mind, a microservice doesn't impact any other service, so you create that microservice. In this case, you just register it in this YAML file, and then upon the next request, it's going to read all of this, and then, like I said, output the proper tool calling, okay? So I'm running really short on time, and there was just one more thing I wanted to show. So let me just quickly do all this. The main thing I want to show is that a lot of this, yes?
There's no one after you, so if you want
Okay.
longer, you can.
Awesome, awesome. Well, I don't want to break you guys from lunch, that's all. But the main thing I want to show is that all of this is kind of low-level coded because I wanted you all to get an appreciation of what's happening behind a lot of the scenes of MCP servers. I feel like, at least for me as a developer as well, it's really easy to just take things for granted. To take things for granted. So going on that lines of taking things for granted, let's see how you can actually take it for granted by using a framework like Pydantic AI, right? The main thing about these frameworks like LangChain, Pydantic AI, and everything is that they abstract away all the complexity that I just showed to you, right? You don't really need to understand how React agents work for you to use the React built-in component within LangChain, for example, all right? So I have this other file, which is using Pydantic, right? And it's super simple. I mean, you can see here that I had so much code for just one MCP client, but within Pydantic, it's like only 26 lines, right? And this is the client-facing agent. So you import the agent from Pydantic, you establish a connection to Anthropic, in this case it's just 3.5, and these are the different servers using the MCP server HTTP object, and then I just list them as servers that this agent has access to, so that when I send the message, the agent can just reason about the same way I just explained, except what you saw before is pretty much what's happening under the hood here. All right? So let me show this to you, and then I will let you all be. Yeah, unfortunately, I need to rerun the Gmail server. I accidentally killed it. Alrighty. So let me just make sure that all the servers are running. Awesome, so the email server is running, the docs email server is running, and this server is running, though it looks really weirdly outputted. All right, so now let's run the whole agent system right there. So let's do uv run agent.py. Now, one thing I will say before I run this is there's very valid reasons why you should use Pydantic AI. And the main reason is that all these developers that make these low-level libraries allow you to use some level of logging that allows you to see what's actually happening under the hood, right? If you've heard of, there's so many tools out there like Arise AI, like Helicone, like Comet, OPIC, and all that. Those are LLM observability tools, right? And in many enterprise applications, it's really, really important to have that level of clarity on what the LLM is outputting, right? With what I showed you, by just coding it all out from scratch, it's really hard to implement that. But Pydantic actually has a tool called Logfire. So the moment I execute this command, you'll not only see granular details on what's happening, but there's this whole UI that's created that allows you to have so much observability on the agent's interactions, which is one of the main benefits as to why you should use some of these frameworks, because it allows for that level of observability. So let me hit run, and it creates this server for me locally. Once again, how to set this up is on the GitHub repository. And all right, so right now, there's nothing really happening here because I didn't ask a question. So let me go back to VS Code, and let's just ask it a simple question. Oh, you can see already here, it pulls some tools that the server has access to. So let me just ask it, what question would you guys like me to ask? My fake transactions.
What category do you spend most money in?
Okay. What category do you spend the most money in? In fact, I'm really glad you asked this because this is not going to work, all right? Let me tell you why it's not going to work. There's actually no tool that supports this kind of query, okay? Right now, the only queries is given a category, right? How much did I spend in it, right? But there is no tool that allows it to get all of that, all right? So let's see how it reasons about it and gives us a response. So you can see here it's outputting a granular level of what's doing. So over here, it's running all the transactions, and let's see what's here. Yeah, over here, I'm assuming it's just because the tool doesn't exist, so it gave that error. But let me just give you a simpler one, like the one I just said before. So give me a summary of all of 10 of my transactions in email, for example. All right, so it's kind of the same one I did before. It's gonna run through everything. In fact, on Logfire, you can see it running live. So let me zoom in. So this is the ongoing request. It ran a tool called sample transactions, which is supposed to because I asked it for 10. It's running a tool called sending the email. I believe that is still running. And then it finally gave an output, which is, I've sent you an email with these 10 random transactions, which is going to show up here, right? The nice thing about this is pretty much the same thing I talked about before, right? It's still doing that React reasoning, except you can really see what's going on under the hood. In fact, over here, if we try to see why it failed, it got some transactions, but the main reason why it failed is an HTTP error. Honestly, I'd have to debug this a bit more. I'm not sure why this is happening, but at least you have that level of clarity when you use a framework like Pydantic. If we want to just ask another question, I realize I didn't really demo like the Google Docs thing. So like, send me your views on 100 of my transactions as a report, right? And my description for the Google Docs server is that this server allows you to create reports, right? So ideally, you should ask that server, what tools do you have that allow me to create a report, and invoke all that. So as it's running here, you can see that it first called sample transactions because I asked it to take 10 of them. And then the output of that is being sent back to Claude, and right now, that's taking some time. So, okay, and then now it's running another tool, which is create report, which is creating a Google Doc, all right? And then it's being sent back to the LLM, and it said here, I've created a comprehensive report of all this. If I go into my Google Docs page and I refresh it, you can see there was one that was created just now, and this is just its report and analysis on 10 of my transactions. All right? So in general, you can always add more capabilities to these servers without impacting the entire system. You just got to define another tool, and that's the real beauty of MCP. And if you want to add another microservice, you can just do it. So kind of a summarizing statement, MCP allows you to change agentic architectures to truly follow microservice architecture. And that's what's lacking without MCP. So thank you, guys. I know we're a bit over. I apologize for that. But if you have any questions, I'll be here for pretty much the rest of the day. Yes. I did, yes. Mm-hmm.
So my question is that the context of the memory of the LLM.
Mm-hmm.
So that's one. I'll ask a set of questions and you can answer all together.
Yeah, of course.
And you have basically two tools. Does the LLM have the knowledge that it can combine the output of those two tools and basically answer that?
Mm-hmm.
The third is that if it updates stuff into the memory context of it and then again tries to pull out of it, are you able to broadcast it to all the servers over there and then they can basically talk how the chat gets done?
Yes. So with regards to your first one, in terms of like using two tools outputs to generate a response, that's actually what you saw it here do, right? Get like 10 transactions, send me a doc. It's two tools. Yeah. It's two tools, and that output is being sent to the user. With regards to your second aspect, in terms of storing like a centralized chat history and sending it to all the servers, you can definitely do that. I didn't do that, but yes, you can definitely store it on the client and then have like another variable in your prompt to do all of that. One thing also that would help address it is, let me actually pull up the docs, because unfortunately 50 minutes, there's not much you can talk about, right? Oh, all right, well, I'm glad about that. This is the official documentation, by the way, and you can see here that the only thing I really touched upon in MCP servers are the idea of tools. In fact, I'll be honest, I think tools are the main things you need. All of these other ones are like easy to implement without an entire interface. But you have this thing called resources, right? Resources allow you to have a specific state for a server, so you can always pull the chat history for that specific server through a resource. So there are other ways to implement it, and this like library has some support for it. Yes, sir, I know you've had your hand up for a while.
Yeah, in terms of the life cycle, what are the benefits of, let's say I have a super simple tool, like are you going to like spin up MCP servers all the time, or maybe you fast forward typing the old way, when you go to production, then you
Yeah.
like what is your viewpoint?
Yeah.
Everybody is gonna like start the MCP server from scratch, is gonna be a
Correct.
tool.
So the way I see it, and this is going to be more of like a business or enterprise question. The way it works is you want to have like a proper roadmap for your product, right? If you're going to have a product that really is just doing one tool and everything, I feel like you have to redesign how you want that product to look like. So in general, like I wouldn't even spin up a server for one tool. I wouldn't even make the product if it was just one tool, right? If it's just for like learning and testing purposes, yeah, go ahead. But for a product, you need to envision like what are all the features the LLM needs access to, right? An LLM is dumb without any context, and in most scenarios, it doesn't have the context you need it to have, right? So you need to give it ample amount of tools for it to invoke one, get the context, and answer the user's question. But there's a limitation there, and the idea is that there was a paper, I forget the exact number, but if you give an LLM more than like 15 tools, it does a pretty job on classifying which tool to execute, especially if some tools are a little bit overlapping in purpose, right? And so having the server architecture and then the tools helps make it a little bit easier. Hence the whole like intent classifying. But now you're able to treat each server, like I said, as a microservice, not as just like a separate agent that you have to do something else with. Sorry, yes, you had your hand up.
Possibly there could be like increasing complexity of how to combine these tools.
Mm-hmm.
I'm curious about how do you look at the reliability of the results and how you evaluate
Yeah.
you're making improvements because there's elements of prompting and a bunch of things
Correct.
involved here.
In fact, to add on to your concern, what if two servers have two of the same tools, right? What do you do there? Because now it's just going to be confused, like, oh, should I use this tool or this tool, and things like that. Because keep in mind, the LLM or the MCP client doesn't have access to the actual code. It just has access to the description of the tool. So what if you accidentally do that? And in my opinion, the way to do that is within your organization, you need to have like a centralized team that maintains these MCP servers, right? One of the main issues is if you have multiple teams making multiple different tools, you'll get into conflicting namespaces, which is that two tools do the same thing. But if you have a centralized organization, you can have a lot more observability on how a tool invocation is working.
Is there a standard evaluation framework for that, how much progress or,
Yeah, I mean, in general, like LLM evals are a good way to start. I guess I'm not the best one to be able to speak on that. I'm not sure right now. But like all of these observability tools like Arise AI, like I mentioned, they all have like evals that you can actually use to test if the LLM output is correct. Being able to do that with centralized tooling, with MCP servers, like I mentioned, I think is really good. In fact, if any of you guys want a startup idea, I'm sure there's a lot of companies willing to pay for that. Yes?
A very basic question. This is
No
not
such thing.
a replacement for agents, right? This would be in addition. So how do you
Yeah.
reconcile autonomous agents
Yeah.
with this architecture?
Actually, a few days ago, did you guys read the whole Google's paper on agent-to-agent protocol? Right? So I wanted to touch upon that, but obviously time. But I would say, like, if you want to like learn more, I'd like learn about that protocol. Where right now MCP bridges the gap between an agent and a tool. But with a multi-agent system, right, there's going to be some gap between an agent communicating to an agent, which then communicates to a tool, right? And so by being able to standardize all that through these protocols will help you actually create a multi-agent system that reaps the benefits of MCP alongside Google's agent-to-agent and things like that.
So last question from my side. If you were to replace the LLM, right? Because
Yeah.
these LLMs are costly, right?
Correct.
There's another provider who comes which is cheaper or things like that. Or if you have a bunch of LLMs that are, I don't want to say LLM as a judge, but like what OpenRouter does.
Yeah.
You have a bunch of LLMs at the back and then you kind of farm out these requests. So where is the state with respect, because this LLM knows about these servers quite a lot, right? How
Correct.
do you do that pattern?
So the way I implement it right now, it's a little bit interesting because the LLM isn't maintaining the conversation history. I pass it in, right? So what I mean is that anytime I have the LLM make a prediction, you can think of it kind of as a quote-unquote zero-shot prediction. It's just I connect to the LLM and I have it make a prediction. That's all I'm really doing. You can replace that with any other LLM or 20 other LLMs. What allows the LLM to like reason and do that step by step is because I'm storing that and I'm sending it as part of the system prompt. So in reality, yeah, I'm using like Anthropic, but say that you find a cheaper LLM, you can just replace Anthropic with another LLM because the LLM's capability I'm using is its reasoning capability, not its ability to remember or not its ability to maintain conversation and things like that. And I'm able to do that because I'm storing all of that and then passing it in as a fresh new prompt, except I give it that context of its previous interactions.
So your eval is your savior over here that makes sure that your system end-to-end is working.
Yeah. And this is the whole idea of like modularity as well. You want to be able to replace your LLM without breaking your system, right? And Anthropic is a pretty expensive model. So if you want to use a cheaper one, like a local hosted Llama, you can very easily do that in general with most agent architectures, but it's definitely true for MCP as well. Yeah.
So if you were to put your CSV or GC file into like OAI, or just like the ChatGPT app, right? You can ask the same question like, well, how do you spend the most money? And then it might be able to actually tell you.
Correct.
So I'm trying to understand this type of why you can do that.
Yeah, and it's because I'm not giving the LLM access to the data. there's a layer of abstraction there. I'm giving the LLM an access to something that has access to the data, right? What you're explaining here is you literally just give the LLM all the contents of the data, and then it's able to query it and so on. But that's not what I'm doing. There's a layer in between. And that layer in between severely impedes the LLM's ability to access that data, because the code there only looks for a specific category and sums that up. So in reality, if you want to have something that's like really broad, you might have to invoke a tool that invokes like an agent. Like LangChain has their like SQL agent. They also have like their experimental Pandas data frame agent, right? So taking the user input, you invoke that tool, you initiate a Pandas data frame agent for that, so it can take in any kind of question and give you that kind of output. The reason why I couldn't do it here is because I'm not giving the LLM the access to the data.
I see. So how, like, if you were in order to answer this question, like, what tool would you create?
I guess in order to, like, is what I just explained. You have an MCP tool that creates just a one-shot agent, a zero-shot agent, sorry, and that zero-shot agent has the Pandas data frame, and it has the user's question, and it has ability to execute Pandas code or SQL code. Like this right here. I don't know why I just forgot how to spell Pandas. Pandas, I don't know what to look, LangChain, yeah, Pandas LangChain. Yeah, create Pandas data frame, right? It takes in a data frame, and then it also takes in a question when you do the run. And this agent behind the scene in the source code has the ability to convert natural language to a Pandas query, execute it, and give you an output. So like to be very, very like modular, I would just invoke a tool that invokes this agent, and it's just a zero-shot agent. It doesn't need to maintain any like user conversation or anything.
I see. So instead of you specifying like sample me, like this.
Correct. Yeah.
To be more flexible.
Also, just to be correct, I think I made a mistake stating like a while ago saying like connecting to an LLM is more of an expensive like operation than actually getting an output. That's not necessarily true, but it is true that like connecting to an LLM every single time you want to make a request or like every single time you want to restart a service is going to be a pretty expensive operation if you do it a lot. One of you, yeah, go ahead.
Is there a standard for like authentication for the server?
Oh yeah. Mhm.
Like how is that just custom?
Yeah. Yeah, I wish someone else, I actually, oh my God, I fully forgot. I didn't implement that because, like I said, that's actually a whole different like concept there. But the main thing here is, actually, this is such a good point, I should have mentioned it. The servers have access to some sensitive information, right? So if an LLM wants access to it, like, you don't want the LLM to give the user some output it shouldn't have access to, right? Especially in enterprise settings, right? If you give it access to Salesforce with some really sensitive customer information, you don't want the user to see it if they don't have access to it. So yeah, through that SSE connection, you're connecting to that server, you can also send in like an API key or an authorization key. So what you'll have to do, and this is gonna be like kind of like a weird system, but like given the user's question, maybe the user is part of a security group on Azure, right? You pull in that token, you pull in what access the user has, and you send that in and every request that the LLM asks, right? So if the user, yeah, and the tools have the ability to like, when they send a request, they need to do the API key. So with every request the LLM asks a tool, it'll have like in its like metadata headers, the API key you can think of, or like the user's like authorization token. So that if the user wants to ask about some sensitive customer information, only if that auth key has the permission to do it, the LLM will get a response. Else the tool will say, hey, you don't have access, things like that. And you pass that in through the sessions. Yeah.
So why does it have to be one tool sort of implemented in one server?
Mm-hmm.
I mean, by that server, you mean physical, so like the actual server, but not like a virtual thing.
Oh, yeah.
Within an actual web serving, right?
Mm-hmm.
Sort of like a server concept.
Mm-hmm.
So it seems to be there's a trade-off, right?
Yeah.
It's more flexible, easy, just treat it as actual server. Then one
Mhm.
long-term server for some tool somewhere you can
Correct.
talk to, right?
Mm-hmm.
With authentication. But there is a downside of that, right? There's a lot of network like
Mm-hmm.
force,
Yeah.
force as well, right?
Yeah, so I will say, when I say server, I'm not talking about like a dedicated like machine. Pretty much what I mean by server is just a system that can communicate to the client, that's all. In fact, when it comes to software development, right, there's 3 levels of virtualization you always need to consider for any system you make, right? You have the actual access to the underlying architecture, so you just launch an EC2 server and you have access to the CPUs, the GPUs. If you're training your own like deep learning model, you might need something like that. But then you have like the next level, which is using Docker containers, right? So that's just a little bit like more virtualized in terms of what you have access to. Then you have serverless functions like Lambdas and everything. For MCP servers, you can just spin up on one machine 20 different like servers, for example, right? Or 20 different Docker containers that do different services and maintain it like that. I mean, even here, only on one machine, I'm running multiple servers. But if you had like so many different servers, right, you could just do it on one machine just with Docker containers.
Different like ports.
Yeah, with different ports, different connectivity, and then now we're going more on the ops side of things, but yeah, you can definitely set that kind of thing up.
Implementation-wise, are they actual web servers, like web servers?
Yeah, I mean, the thing I showed you like the Starlet messaging endpoint. Starlet is like the framework behind like Fast API, which itself is an asynchronous web framework for making asynchronous requests. So it is like a web framework, and you can see that because it's running on a specific port, listening to incoming requests and maintaining it. It's still a protocol the way like REST is a protocol and everything. The main thing that defines MCP is what methods or what the protocol allows you to do to the server, right? You can't make a GET request you can't make an HTTP request to an MCP server, but you can make like a call tools request to an MCP server because the protocol defines call tools as like a method.
Yeah. I'm asking because it feels like it's expensive if it's just a very simple tool. Then you have like a server, specific server being built.
Oh yeah, definitely. I think the main way to like conceptualize is to like think on like a really, really large scale, and also think about on a scale where you have one centralized team, and there's 100 teams within your application trying to access the same tool, right? Then you'd want to have like a more or less like dedicated infrastructure to take in all of those requests, scale all of those tools based on incoming requests. In a very simple sense, where you only have like 3 tools, you only have 3 customers, then yeah, this might be overkill, but it's still like there are still like benefits to it, and so it's really up to you to decide if the costs outweigh the benefits. Yeah.
I don't want to keep you for too long.
No worries, I have all day.
Question of context,
Mhm.
keeping things in memory or something along those lines.
Correct.
Is there any role that RAG plays in this architecture, or is it not the best practice?
Oh yeah, for sure. I mean, lots of good questions that I didn't touch on. You see here in this diagram, I have this little white arrow that I didn't touch on, which is like external data, for example. So you can always do a tool invocation like anytime. It's just really like making sure, like, by the way, like MCP doesn't force you to do something a certain way, right? So you could just like fetch a specific data store on the MCP client, and then anytime you make a request to the server, you give it that context, right? Or you could just have a dedicated server for RAG, and then with it like fetches the relevant data and it invokes other tools. It's really up to you. Like, you're not forced to follow this pattern in a very stringent way. All MCP allows you to do is what I just described, just communicate to a server. But if you want to do RAG, you could technically do it on the client side, you could do it on the server side. I mean, for the best like design structure, you might just do it on the server side, have a dedicated server for it. But it is really just up to you. There is no like set way to do that. Yes. Sorry about that. Yeah. Of course. No, thank you. Yes, take care.